gravity in their experiment? Put your hand up.
Who is a superhero today? Yes?
Alright.
3 people.
Over here too, yes?
Who managed to defy it in the aeroplane experiment? Can you put your hand up? Using the paper plane.
Even if it was for a few seconds.
You?
Fantastic. What did you find a force that might be present? What did you think that was?
Well, there was our force, like applying the force, made it go through the air, so it was like resisting the air and the gravity.
Fantastic. So maybe your large wings resisted the air and your force of throwing. Fantastic. What about the cake mix? Who managed to defy gravity and make the cake mix fly? Fantastic. Can you tell me what happened?
The mixture went everywhere.
Well done. And did you work out why you thought? Was there some sort of force that made the mixture fly outwards and everywhere?
The spinning of the egg beater.
Fantastic. What about our hairdryer experiment? Who managed to defy gravity and make those balls fly in the air? No one?
Some of the balls.
Yeah,
Yeah?
the foam one.
The foam
Yeah.
ones? And what was making them defy gravity?
The air is pushing.
The air push up.
Yeah.
Fantastic. So that could be kind of an example of our air resistance that we were talking about before, but with the hairdryer, it just made it more visible for you to see. And what else?
What about the buckets? The spinning of the bucket. Who got wet? Not too many people? Who did you think? Did you defy gravity there? How did you defy gravity? Spinning the word centrifugal, that's right. The force of centrifugal pushed the water back into the bucket, but gravity kept it in your orbit around your shoulder, didn't it?
What about in the spinning activity, but like seeing the gravity and the force between the Earth and the Moon? We didn't get it working on all of them, but most of them got them working.
What did you see there?
Did the larger wave, did it just fall?
No, the spinning motion made sure that it sort of maintained its height and stopped gravity from
So
working
the
on it.
force of the spinning moon kept the Earth suspended.
So, if we go back to our question, we told you that 3 of our experiments were going to help you answer our question. Does anybody think of any of the experiments that might help us answer our question? Yes?
The bucket,
How come?
because we got to see the spinning and the gravity at the same time, and with the centrifugal it wasn't moving.
So well done. So how do our planets move around the Earth, around their sun? They rotate and they spin. Well done. So the planets rotate and spin around the sun. What's the sun's gravity? And what did we see that this spinning force was doing in our experiments?
That's right.
Pushing stuff outwards.
Away
Fantastic.
from the centre, wasn't it?
So let's see. So gravity's pulling our planets inwards. But we wanted to know why the gravity doesn't pull them all right in so that they crash into the sun. We've worked out that a spinning motion on Earth, spinning motion pushes things outwards. Can anyone answer our question today, think?
So they counteract each other and just keep them going around.
Well
The
done.
sun pulling in with the bed there pushing out, so that counteracts and doesn't make them all push.
That's right. So
Fantastic.
centrifugal pushes them out, but gravity keeps them in the orbit, doesn't it?
Who came?
It really is a system of forces.
Yeah. So who came up with an answer to our question similar to what Cara just suggested? Few people, good scientific thinkers. All right, so we've just got a bit of an example to demonstrate that. So this ball on the string, I want you to imagine that this string is the gravity. Now this ball, I'm the sun, this would be a planet. So at the moment, where's the gravity? The gravity's just pulling, where's the gravity pulling the ball? Down. What happens if I do this? It's staying up. So if I'm the sun, I want you to imagine that that string is the gravity pulling the planet inwards. But what's the spinning motion of the planet making it do? If I let go of this string, what would happen? It'd fall, and I'm not going to do it now. I might do it on the ground. But if I'm going to let go, what do you think will happen? There you go. So,
Because every object in motion stays in motion unless an external force is applied to it. So what's the external force?
finish up, we thought we'd use what you know about gravity to see if you can identify what the force is to defy gravity in these examples. So gravitron, has anyone been on a gravitron? So what happens? You kind of fly out and stick to the walls, don't you? So what's the gravitron doing to make you do that? Spinning. So that's a good example of the forces we were
And in
exploring.
a lot of our experiments, we did see that spinning keeps things together.
What about this one? What do you think the forces are that helps this plane defy gravity? Those of you who did the paper aeroplane example might be able to help us.
Speed from the engine that keeps it going.
Well done. And the air. And what about with this one? Air, fantastic. So as it's flapping its wings, it might be pushing down on the air resistance. Hang glider, probably do something similar in the parachute. What about this guy walking up the stairs? Is he defying gravity? Is there some sort of force that's helping him defy to go up the stairs? The Earth's pulling him down.
So is motion like pushing forward through
Fan-
the air?
Yeah, fantastic. It's his legs pushing against the step. Our muscles give us force. So even me picking up this stapler, I'm defying gravity already. What about this one? Is there anything else there that helps this rocket go up?
Force of the rocket, so the upward force it gives it.
And what about this fire? What do you think that would be? Is heat a force? I don't know.
Maybe it's the thrust from the heat that pushes it upwards.
Maybe we could explore this next lesson. There we go. So yeah, there's some possible future lessons. We were thinking maybe if we wanted to explore the rocket ship, we could light some tea bags and saw how rockets defy gravity, or take this however we like.
Yeah, we're just the good question of what we came up with as well, because we thought, maybe kids, that's what this lesson extended from, was a really good question that we wanted to answer, or get you as students to answer. So,
And that's it. Thank you very much. We just wanted to know if there's any strengths, weaknesses, improvements, or modifications that.
I thought it was good how you did the example at the end again, like if you had an example at the start.
Yeah.
And a lot of people don't have like concrete at the end. It was good because that like made me understand more what we were doing.
Oh, good. Yeah, we thought that for those who came up with the answer, they would be right, but some kids in the class might not have come up with it, so we thought we might do something else. Thanks.
I really liked how all the activities were relevant, but also at the start, like, not many of us have actually like taught that we're going to be taught the concept before we've actually done it, and you like taught it before we did it.
Well, we, as when we were researching, we were a bit mind-boggled, and we were like, this is a really tricky concept, so we thought we were doing experiments to see, and then we chose to do those experiments.
we chose the simpler ones as well, because it's a really, as Kate said, it's a really difficult concept to get your head around. So maybe just doing the simple ones to see how it works on a small scale and apply it to the big scale of the planet.
Yeah, I think it's good that that was how you knew it well enough to simplify it for us. It could have been something that became really complicated, like even the say centrifugal. Like you explained it enough. I know it's a big word, but you understand what it is. Where I think that could have gone wrong. That makes sense. But all of it was really to the grade 5-6 level, and it made sense.
Because we were looking at harder experiments, and we thought it's probably going to go. It was going over our head, so it's more than likely going to go over a grade 5-6 head.
Yeah, we kind of thought, I don't know if this is true of teaching science, but we kind of thought that if you're going to do complicated experiments, the level of thinking might need to be simple, and they need to be comfortable with the level of thinking they're doing. But with simple experiments, then, because they're familiar with these sort of activities, all they're doing is flying planes and mixing water, but then you can do complicated thinking that they haven't done before. So that's kind of
every
the theory
day.
we were
Kind of stuff
doing.
that you do at home.
Well, we found all these things at home anyway.
Yeah.
I like the way you based it all on questioning and inquiry. I thought that was really good, really student-centred, and that's what science should be. It should be answering questions of the
How we started